Ever pondered the possibility of a volcanic eruption happening right under your feet? Now that's a thought to send shivers down your spine. But it's not as far-fetched as it might seem. Today, we're diving into the intriguing and somewhat unsettling world of volcanic hotspots. These hotspots, contrary to their name, aren't cozy little nooks where you can curl up with a good book. No, these are regions deep within the Earth's mantle where heat rises, creating a plume that can puncture the Earth's crust, causing a volcanic eruption. They exist all over our planet, silently churning beneath our feet. Now before you start packing your bags and planning a move to Mars, let's get one thing straight. Not every hotspot leads to a volcanic eruption. Many are dormant, their fiery potential locked deep within the Earth. But here's the rub. Some are active. And it's these active hotspots that could, at any given moment, decide to wake from their slumber and remind us of the planet's raw and untamed power. This might seem like a plot straight out of a Hollywood blockbuster, but it's a reality that scientists are grappling with daily. As we go about our lives beneath us, the Earth's tectonic plates are shifting, creating the perfect conditions for these hotspots to strike. So how do these seemingly innocuous geological features translate into potential mass destruction? Well, it's all about location, location, location. Most hotspots are located in the middle of tectonic plates, far from human habitation. But some, like those under Yellowstone National Park or the Hawaiian Islands, are nestled uncomfortably close to us. These hotspots, if they were to erupt, could cause untold devastation. We're talking about a force that has the power to reshape landscapes, alter climates, and yes, even wipe out entire species. So, next time you're enjoying a picnic in the park or a walk on the beach, spare a thought for what might be lurking just beneath the surface. Imagine the unthinkable, a volcanic eruption in your backyard. Scary, isn't it? So, what exactly are these volcanic hotspots that we're talking about? Well, let's dive right into it. Imagine a monstrous cauldron of molten rock, or magma, that's been lurking deep beneath the Earth's crust. Now picture that cauldron finding a weak spot in the crust and breaking through, creating a persistent source of volcanic activity. That, my friends, is a simplistic image of a volcanic hotspot. But how do these hotspots form, you may ask? It's a fascinating process, really. The Earth's mantle, which sits beneath the crust, is a swirling sea of semi-liquid rock. Sometimes a plume of this hotter-than-usual rock rises towards the surface. As it does, it melts the overlying crust, forming a pool of magma. This magma, under immense pressure, forces its way up through the crust, creating a volcanic hotspot. Now, where are these hotspots commonly found? Well, they can pop up pretty much anywhere on Earth, but they're most often found in the middle of tectonic plates rather than at the edges where most volcanoes are. The Hawaiian Islands, for instance, sit squarely atop a volcanic hotspot, as do the Galapagos Islands and Yellowstone National Park. That's right, Yellowstone. The park's famous geysers and hot springs are surface manifestations of the massive hotspot simmering beneath. These hotspots remain active for millions of years, creating chains of volcanoes or islands as the tectonic plate above them slowly moves. But here's the kicker. Hotspots, unlike typical volcanoes, aren't tied to the boundaries of tectonic plates where seismic activity is more easily predicted. They can occur smack in the middle of a plate, making their eruptions far less predictable and potentially far more destructive. So while we enjoy the beauty of places like Hawaii and Yellowstone, it's crucial to remember the immense power that lies beneath. In essence, a volcanic hotspot is like a ticking time bomb, silently waiting beneath the Earth's crust. Now let's delve deeper into the science behind these hotspots. Picture a pot of soup simmering on the stove. The heat source beneath the pot is like the Earth's core, radiating energy outward. This energy heats up the mantle, a layer of rock beneath the Earth's crust, much like the soup in your pot. The heated mantle rock begins to rise, just as the heated soup rises to the surface, creating what we call convection currents. This is the first step in the creation of a hotspot. As the heated mantle rock rises, it moves towards the Earth's crust, the top layer of our soup pot. But here's where things get interesting. The Earth's crust isn't one solid piece, but rather, it's broken into several large pieces, known as tectonic plates. Think of these like the skin on top of your simmering soup, breaking and shifting as the heat rises. Now, imagine a particularly strong column of rising soup, or in our case, heated mantle rock. This is what we call a mantle plume. When a mantle plume pushes against a tectonic plate, it can sometimes create a break or weak spot. This allows the heated mantle rock to break through, much like a bubbling surge of soup might break through the skin on top. Once the mantle rock breaks through the crust, it cools and solidifies, forming magma. Over time, this magma can accumulate and create a volcanic mountain, but not all of this magma makes it to the surface. Some of it stays hidden beneath the crust, creating a hotspot. These hotspots can remain active for millions of years, with the mantle plume continuously supplying heat and magma. Over time, as the tectonic plates move, the hotspot can create a chain of volcanoes like the Hawaiian Islands. And voila, a hotspot is born, hidden beneath the Earth's surface, potentially leading to a volcanic eruption. But what happens when these hotspots finally decide to make their presence known? Well, the answer to that lies in the destructive potential of volcanic eruptions. Let's take a trip down history lane, shall we? Picture the year 1818. The world was left in darkness and despair due to the eruption of Mount Tambora in Indonesia. The eruption was so intense that it led to what is known as the year without a summer. That's right, the entire world experienced lower than average temperatures, leading to widespread crop failure and starvation. A single eruption impacted the whole globe. Now, fast forward to 1980. Mount St. Helens in Washington state roared to life. The eruption resulted in a death toll of 57 and caused billions of dollars in damage. The ash cloud from the eruption was so dense that it turned day into night, and it was visible from space. These are just two examples, but they perfectly illustrate the dangerous potential of volcanic eruptions. They not only cause immediate destruction in the form of lava flows, pyroclastic flows, and ashfall, but the long-term effects can be equally devastating. Eruptions can change weather patterns, leading to unseasonably cold temperatures or droughts. They can alter landscapes, burying once thriving ecosystems under layers of ash and lava. And let's not forget the human impact. Aside from the obvious threat to life, eruptions can displace communities, destroy infrastructure, and disrupt economies. Moreover, the gases released during eruptions like sulfur dioxide can mix with water vapor in the atmosphere to form acid rain, which is harmful to both the environment and human health. And it doesn't stop there. These gases can also contribute to climate change. Large eruptions can pump enough particles and gases into the atmosphere to cool the planet, at least temporarily. The sheer power of volcanic eruptions is a stark reminder of the formidable forces of nature. They are unpredictable, uncontrollable, and undeniably impactful, a testament to the volatile world beneath our feet. The future of volcanic hotspots remains shrouded in mystery. As we delve into the unknown, scientists around the globe are tirelessly working to predict and better understand these enigmatic hotspots. This task, as you can imagine, is not without its challenges and uncertainties. Volcanic hotspots, despite their destructive potential, are remarkably elusive. They lurk beneath the surface of our planet, hidden in the deep, churning layers of the Earth's mantle. Detecting them before they erupt is akin to finding a needle in a haystack. Yet our scientists are undeterred. They employ advanced technologies from seismic imaging to satellite surveillance to scour the globe for these potential threats. However, prediction is only part of the equation. Understanding why and how these hotspots form is another vast field of study. Scientists delve into the complex interplay of geologic processes from plate tectonics to magma formation. Each new discovery unravels another layer of the puzzle, bringing us closer to comprehending the nature of these volatile formations. Yet the road to understanding is fraught with uncertainties. The Earth's interior is a dynamic, ever-changing environment. Conditions that trigger a volcanic hotspot today may be entirely different tomorrow. What's more, our planet is vast, and we've barely scratched the surface of its mysteries. Each new hotspot discovered is a reminder of how much we still have yet to learn. Moreover, the unpredictable nature of these hotspots poses a significant challenge. They can remain dormant for thousands of years, only to awaken suddenly and explosively. Predicting when and where this might happen is an ongoing effort, one fraught with many unknowns. Despite these challenges, our pursuit of knowledge remains steadfast. Scientists continue to improve our predictive capabilities, refine our understanding, and work towards mitigating the potentially devastating effects of these hidden threats. We stand at the frontier of discovery, peering into the depths of our planet with a mix of trepidation and anticipation. As we continue to probe the depths of our planet, we may yet uncover more of these hidden threats. So, there you have it, the fascinating and terrifying world of volcanic hotspots. Today we've journeyed into the fiery depths of the Earth, unmasking the locations of these hotspots and shedding light on the science that fuels their heat. We've delved into the impact of volcanic eruptions, from the creation of new landforms to the devastating destruction they can unleash. The existence of these volcanic hotspots is not a matter of fiction or speculation, but a reality we grapple with. Their formation, driven by the Earth's dynamic internal processes, is a testament to the powerful forces shaping our planet. But with this knowledge comes a sobering reminder of the potential danger they pose. The future of these hotspots remains unpredictable, much like the world above us. We must continue to study, to question, and to prepare for the power that lies beneath our feet. Remember, the Earth beneath us is as dynamic and unpredictable as the world above. Stay curious, stay informed, and most importantly, stay safe.